One aircraft does something no stealth fighter has ever done before. It takes off from a ship the size of a parking garage. It hovers like a helicopter. It fights like a fifth-generation fighter. And it lands vertically on a deck pitching in ocean swells. The F-35B Lightning II is the most complex aircraft ever built. It costs more per unit than any fighter in history. It nearly bankrupted the entire Joint Strike Fighter program, and it works. From amphibious assault ships to damaged runways to jungle clearings, the F-35B operates where conventional fighters cannot reach. It gives Marines and Allied forces stealth air power without requiring massive aircraft carriers or 10,000-foot runways. But not every F-35B is identical. From early test aircraft that could barely fight to current models carrying the most advanced sensors on Earth, the variant has evolved dramatically. This is every F-35B variant ever made explained. The origin, why STOVL, 1993. The F-35B exists because the Harrier was dying and nothing could replace it. Since the 1970s, the AV-8B Harrier II gave Marines something no other service had: jet air power from small ships. While the Navy launched fighters from massive supercarriers, Marines flew Harriers from amphibious assault ships 1/3 the size. They could deploy anywhere, support ground troops directly, and operate without massive naval infrastructure. But the Harrier had brutal limitations. It couldn't fly supersonic. Its radar was a generation behind. It carried fewer weapons than conventional fighters. And it killed pilots at an alarming rate. The Harrier's accident rate exceeded every other tactical aircraft in American service. Vertical flight was that demanding. By the 1990s, the Harrier was approaching obsolescence. Enemy air defences were improving. The aircraft couldn't survive against modern threats. As the Marines needed a replacement that could hover like a Harrier but fight like an F-16. That requirement nearly proved impossible. In 1993, the Joint Advanced Strike Technology Program began exploring options. By 1996, it evolved into the Joint Strike Fighter competition. The requirement for a STOVL variant, short takeoff and vertical landing, was the most technically challenging element of the entire program. Two companies proposed solutions. Boeing offered the X-32, so using direct lift from a swiveling engine nozzle. Lockheed Martin offered the X-35, using a revolutionary shaft-driven lift fan combined with a swiveling rear nozzle. The competition would determine whether STOVL stealth was even possible. X-35B, the competition, 2001. June 23, 2001. Edwards Air Force Base. The X-35B does something no aircraft has done before. Test pilot Simon Hargreaves takes off in less than 500 feet. He accelerates to supersonic speed, reaching Mach 1.05 in level flight. And he returns to the runway and lands vertically, touching down with helicopter-like precision. Short takeoff, supersonic dash, vertical landing, all in one flight. No previous aircraft had achieved this combination. Boeing's X-32B had attempted the same demonstration and failed. The aircraft couldn't complete all three phases in a single mission. Technical limitations forced Boeing to modify the prototype between vertical and conventional flight modes. The X-35B did it without modification, whereas the lift system worked exactly as designed. October 26, 2001, the Pentagon announces Lockheed Martin as the winner. The X-35 becomes the F-35. The STOVL variant becomes the F-35B. The contract is the largest in military aviation history. Over 3,000 aircraft planned across 3 variants, hundreds of billions of dollars, 9 partner nations, and the F-35B is the most difficult variant to build. F-35B, Block 1, A/1B, 2012. The first production of F-35Bs can barely fight. Block 1A aircraft are delivered starting in 2012, are essentially training platforms. They can fly, they can hover, they can land vertically, they cannot employ weapons effectively. The software is incomplete, the sensors are limited. These aircraft exist to teach pilots how to fly the F-35B, not how to fight with it. Block 1B adds limited air-to-air capability. Pilots can employ AIM-120AM, RAAM missiles in certain scenarios. The aircraft can participate in basic combat training, but significant limitations remain. The Marines accept these aircraft knowing they're stepping stones. The Harrier is aging out. Pilots need to learn the new systems. Training aircraft are better than no aircraft. Approximately 60 Block 1 F-35Bs were built before production advanced. Most have since been upgraded or relegated to permanent training roles. F-35 B Block 2A/2B 2015, July 31, 2015. Marine Fighter Attack Squadron 121 at Yuma, Arizona, declares initial operational capability. For the first time, the F-35Bs are cleared for combat deployment. The Marines become the first service worldwide to operationally deploy the F-35. Block 2B aircraft can employ a limited but meaningful weapons suite. AIM-120, AMRAAM for air-to-air combat, GBU-12 laser-guided bombs, GBU-32 GPS-guided bombs. The aircraft can fight. The AN/APG-81 radar is active, though not at full capability. The AN/A AQ-37 distributed aperture system provides 360-degree infrared coverage around the aircraft, so your pilots can see threats in every direction simultaneously, including behind them. The sensor fusion that defines the F-35 begins working at Block 2B. Instead of displaying separate radar, infrared, and electronic warfare information on different screens, the aircraft combines everything into a single, tactical picture. Pilots see the battlefield, not sensor feeds. Block 2A aircraft have slightly less capability, serving as advanced trainers with some combat potential. And the Marines push hard for rapid deployment. Critics argue the aircraft isn't ready. Supporters counter that any F-35B capability exceeds what the aging Harrier provides. Getting aircraft into operational squadrons, learning how to employ them, matters more than waiting for perfection. History validates the aggressive timeline. Squadrons gain experience, tactics develop, problems are identified and fixed. By the time Block 3F arrives, crews know how to fight. F-35B, Block 3F 2018. Block 3F delivers what the program originally promised: full combat capability. The software finally reaches design specifications. All planned weapons integrate fully. The sensors operate at complete capacity. Years of development delays end here. The weapons suite expands dramatically. AIM-9X Sidewinder missiles for close-range dogfighting. Small diameter bombs for precision strikes with minimal collateral damage. At the full range of precision-guided munitions the internal weapons bays were designed to carry. Internal carriage matters for stealth. Weapons hidden inside the fuselage don't reflect radar. The F-35B maintains its stealth signature until the moment of attack. When stealth no longer matters, external pylons double the payload. The AN/APG-81 radar reaches full performance. Detection range extends far beyond anything the Harrier ever carried. The radar tracks dozens of targets simultaneously while continuing to scan. Electronic warfare modes allow jamming enemy systems while fighting. Block 3F also enables full data link integration. F-35Bs share sensor information with each other, with other aircraft, and with ground forces in real time. One aircraft detecting a target instantly shares that detection with every friendly platform on the network. The squadron fights as a unified sensor array, not individual jets. Production transitions to Block 3F standard around 2018. Earlier aircraft upgrade progressively. The F-35B is finally complete. F-35B, Block 4/TR3, 2023 to present. Block 4 represents continuous modernization rather than a single upgrade. Under continuous capability development and delivery, Lockheed Martin releases software and hardware improvements incrementally. New weapons integrate. New capabilities appear. The aircraft evolves constantly rather than in discrete blocks. Technology Refresh 3 provides the hardware foundation. New processors dramatically increase computing power. Memory and data storage expand. The aircraft can run more sophisticated software, integrate more sensors, and process more information simultaneously. New weapons integration continues. The AIM-260 Joint Advanced Tactical Missile will eventually provide extended-range air-to-air capability. Hypersonic weapons may integrate in future updates. The weapon's bay and pylons support munitions that don't exist yet. The most significant Block 4 capability may be sensor enhancement. Radar upgrades improve detection of low observable targets. Electronic warfare systems expand. The aircraft becomes more survivable against evolving threats. Block 4 development has faced delays and cost growth. The TR3 hardware transition caused production slowdowns in 2023 and 2024. Aircraft awaited software certification before delivery. The challenges reflect the complexity of integrating new technology into an already sophisticated system. As of 2025, TR3-equipped F-35Bs are entering service. The upgrade cycle continues indefinitely. Future F-35Bs will have capabilities today's aircraft lack. Outro. From an impossible engineering challenge to operational squadrons on 3 continents, the F-35B proved that vertical landing and stealth can coexist. Approximately 300 delivered, 6 nations operating or committed. And the only STOVL stealth fighter in existence or development worldwide. The designers achieved what Boeing couldn't: short takeoff, supersonic flight, and vertical landing in a single airframe. They gave Marines stealth capability from ships 1/3 the size of supercarriers. They created an aircraft that operates where nothing else can reach. The F-35B cost more than any fighter in history. It nearly broke the program during development. Every criticism was valid at some point. It flies anyway. It fights anyway. It works. If any variant stood out to you, I've linked detailed replicas and reference materials in the description, completely optional for anyone who wants to explore further. The F-35B Lightning II, the impossible aircraft that became operational.